Okay, so the topic of my presentation is realising your design with Solidworks and 3D printing. We're Solid Solutions Ireland and director there at the company. So just having a quick look at traditional design routes. And traditionally in design, we went from our concept to detailing our product, to creating an actual physical prototype, testing that, whether it was destructive testing or not, or physical testing, and then we did final product development, and then eventually we got to actually manufacturing that product. Now in today's modern world, we want to reduce that value chain dramatically, because we want to get to time to market quicker. So a lot of this is happening at the very front end as we design. So we can literally run a lot of these processes concurrently. Create our design, manage our data, create a rapid prototype with 3D printing. We can also do simulation on our design as well, and maybe create those technical documentation, work instructions that we need. And hence, we're getting a product to manufacture quicker, and that's reducing time, cost, and money. So the automatic design process. So initially, we must have a requirement, okay, and then we literally take across into design. We can then simulate that design. In other words, we can do an FEA analysis, so we can see how that design is going to actually perform in the real world, whether it's a force or a flow analysis on the part. We can then refine that design depending on the results we get. And maybe if we're happy with that, we want to get some form of product or something that we can physically put in our hand. Now with the advent of adaptive manufacturing or 3D printing, we can print that very, very quickly. There is now no excuse for an engineer not to have a 3D printer sitting on his desktop. As was mentioned earlier on with the FDM machines, they've become very, very affordable. So it helps us to choose our prototype and get to market quicker. So the benefits are, compared to the alternative design concepts that have been there in the past, we're reducing and eliminating costly design changes later on down in the process. The last thing we want to do is have something manufactured and then realise, whoops, that doesn't work, or that doesn't fit. Okay, we're back to the drawing board and we're starting off at the beginning of the process all again. Why not find that out earlier in the design process and give a little bit more time at the concept and design stage? It's cheaper in the long run. So I just want to bring in some of the ideas of design and what can help you with that design. The likes of SolidWorks 3D CAD, where you can create that 3D model. It's intuitive, it's easy to use, you can generate your 2D drawings very quickly from that, but the data is easy and safe thereon afterwards, okay? So you can communicate, you can send that out as an STL file. If there needs to be work, you can import STL files and deal with sliver faces before you bring them to 3D printing. When we've that 3D model completed, we can simulate it, okay? So in other words, we want to see maybe forces or pressures or a drop test on a phone or maybe flow analysis around a turbine. This can all be done through simulation, through the actual software. And we can see the MyOmo arm, which was, a lot of it was 3D printed, but also designed in 3D CAD, tested before brought to a 3D printing stage. So with the simulation tools, we can, which are fully integrated within the SolidWorks package, we can understand real-world behaviours from structural simulation, flow simulation, injection moulding, even down to flattening surfaces and how stretch will affect that surface as it's been stretched over a component. So early in the design process, we can select best alternative designs without manufacturing or creating any prototypes. So what simulation helps us do is eliminate the amount of prototypes we actually create. So the next thing we want to do is communicate those designs. So we've got our design, we've reduced our prototypes, now maybe we need to communicate that. And there's a number of tools that can help us doing that. And that is the likes of Composer for documentation, like your Haynes manual. Visualize for creating your visual 3D rendered images, magazine quality. And then maybe for inspection documents or mechanical based definitions and drawings, where you can send those out to customers and they can actually manufacture from those as well. But this leads us on to then the 3D printing. So we've our CAD created, we've acceptance from the customer, he likes what he sees, the visual images he's got are spot on and he's happy to roll with that, but he wants to see a physical model in his hand. Well, from that SolidWorks data, you can send directly to 3D printing. And we've two types of flavors. We're now selling 3D systems printers and also a smaller Syndo FDM machine. But this helps us create the prototype and test procedure with those particular printers. So we can print functional production parts. We've one customer who creates blinds, or manufactures blinds. They design them within SolidWorks. They actually had a flaw in their design. And the solution to the problem was very, very simple. It was a little nodule that allowed it to fit onto the rail. But they hadn't got time to send it back for manufacturer or redesign it. So what they did was they designed a little component and 3D printed it on an FDM machine, and it's running 24/7, these little FDM machines, printing out the actual solution to the problem till the next batch come. And that's happening in the real world, and it saved them. The machine was only, the FDM printer was only $2,000, and it saved them an absolute bucket of money. But with the printers, we can create rapid tooling, injection molding parts, many different prototypes and concepts. So the range of printers we're offering is the 3D Systems Project. So if you want a full color, CMYK color, we can do that on a X660 series. We have those inside. Again, any flow analysis or FEA analysis, and you want to print it, that will print on this machine. You can see where the stresses are on your component. The next printer in the range is the 2500, which has become very, very popular. And that will print to an accuracy of 32 micron layers. So you're, plus or minus 0.1 of a millimeter over 25 mil or an inch. It's outstanding quality parts, and that will actually print in rigid material or elastomer material as well, so a rubber-like material. We have samples over on our stand, Solid Solutions, it's 113. And then with the high-end 3D Systems printer, the 3600, and that's more accurate. Okay, so that'll print to 15 micron layers, or 0.025 of a mil over 25 mil. It's outstanding quality. You can actually print in a clear VisiJet material, which is Class 6 approved, okay? And it's high strength ABS-like material. So we've done quite a lot of work with that actually. One of our customers is printing out particular molds for the heart. They're developing little components that would fit within the heart to stop strokes. And again, they're getting a lot of the models printed on the 3600. So we're taking files from a CT scan, bringing them into SolidWorks, creating that file, and then printing it out on the 3600. And finally, new to the market is this new product, Syndo 3D Walk. We've taken it on the last 12 months. It's a gold partner to SolidWorks, and it sits within SolidWorks, and it can print directly. It's a desktop 3D printer. Every engineer should have one of these. They're very reasonable, 1,600 plus the VAT or something like that. But you can print directly. You can monitor your print over the web, and it's very, very easy to use and set up. So it's an automatic adjusting build. We've one of them running over on the stand. You can get that product created, manufactured, or you can actually just print it to see what's happening. This is the little printer I was telling you about, that company that did the blinds. This is the little printer they're using, printing on PLA material. So this will print PLA and ABS.